We're going to talk about fiber, and if you have questions as I go through the presentation, by all means, get my attention somehow, and I'll be glad to address your question at the time. You don't have to wait till the end. Wanted to give you a little history on fiber. Fiber has been used in concrete for many, many years, as it says there. Back in the early years, fiber was used by the Romans. The Romans developed fiber, and they actually used this product right there, the horsehair. Then along comes this product that I'm sure you are very familiar with, asbestos, which is not a good product to deal with because of the carcinogen effect that it has. But when those fibers came on the market, were used for a while in the 1900s, and then when they realized the danger with that, then all of a sudden in the 60s, we see steel, glass, synthetic. That's your polypropylenes and your polyethylenes. So all different types of materials out there today, everything from nylon to glass to steel to synthetic, and we're going to talk a little bit about all of them. So why do we use fiber in concrete? What's the purpose of using fiber in concrete? And I think the best thing to say is to do this right here, to control the cracking, whether it's early age cracking from plastic shrinkage, temperature shrinkage cracks at the surface, or from drying shrinkage and things like that as the concrete cures and as the concrete sits there for years. So we're going to talk a little bit about all of this, but mainly, why we use fiber in concrete, we want to control the cracking. So, we're going to discuss things like replacing welded wire fabric with fiber, replacing even rebar with fiber. The macro fiber that I'm going to introduce you to today is a structural fiber, meaning that it can handle bending moments. So it is a structural fiber. We'll talk more about that here shortly. So why should you use fiber in your concrete? Well, why should you use fiber in your concrete? One thing it does, it absolutely increases the toughness and durability, whether it's, a residential project that you might be working on or an industrial project that you might be working on. You could have a need for micro or macro on either. Just because it's a micro fiber does not mean that it's always going to be used in just a residential application. I mean, we use microfibers in industrial, commercial applications, just like we use macro fiber in residential applications. So we can mix and match, and we'll even talk about this thing called blended fibers, where we have macro and micro combined in the same product. But first reason here why you need to consider using fiber in your concrete: increases toughness and durability. Again, here's a big one: decreases cracking. Again, whether it's the early age plastic shrinkage cracks or temperature cracking, reduces cracking. If you're looking to reduce, cracking for industrial applications, like I said, macro fibers, great choice for that. So certainly, addresses your cracks. One thing about concrete is, that product is known to crack. So fibers will certainly help to fight, against cracks occurring. But, I don't think there's anyone out there that will tell you that, hey, by the use of fiber, you're not going to have any cracks. We're not going to tell you that. We will absolutely put our best foot forward to try to prevent any cracks. But we're not going to, guarantee that you have a crack-free slab simply because of the product that we're working with. I mean, that's just, it's just what concrete does. I guess the phenomena is that it doesn't crack worse than it does when you look at the ingredients that it's made of. So anyway, another reason: decreases cracking. So nobody wants to see cracks, whether it's their garage slab, whether it's their industrial floor, their sidewalk. I don't like seeing cracks in my driveway. So fiber helps to reduce cracking. Another big thing that it does, it improves the freeze-thaw resistance. So, as concrete is porous, And when it's moist, wet, whatever you want to say, in cold temperatures, you probably not a big deal in Barbados. I don't know what the low temperatures get in Barbados. Probably not a lot of freezing temperatures, I wouldn't think. But you know, here where I'm at, we see, you know, freezing temperatures all the time in the winter. So when that water, you know, infiltrates these pores and it freezes, well, it does just that. Those three little drawings you're looking at is what the water does is, you know, when it freezes, it expands. Well, when it expands, those forces and pressures go somewhere, and what they do, they cause the concrete to crack. So fibers can help hold those cracks tight. Even if it does crack, it will certainly hold them tighter than if, you know, nothing was there. This is a big one. Reduces the effects of shrinkage. Of course, you know, it's all about the shrinkage, as it says there. During the curing process, concrete experiences shrinkage as the water evaporates. You know, the fibers can help improve the concrete's resistance to the shrinkage and will in turn reduce its cracking. So what I like to say is, when you control the shrinkage, you control the cracking. Okay, so if we can control the shrinkage in the mix, and if we can control the shrinkage in the mix, we can control the cracking, you know, of the concrete. Now, in the mix, you know, not everything in the mix is shrinking. You know, your stone's not shrinking, your sand's not shrinking, but what is shrinking is your paste, your cement. You know, even your fly ash. There's no, you know, your fly ash. If you've got fly ash in the mix, it's not the part that's shrinking, but it's the cement that's shrinking. So we try to control that. Now, lastly is aesthetics. You know, everybody wants their concrete to look good. Again, you know, cracks are not pleasing. Nobody wants to see cracks. Again, in whether it's their floor, their sidewalk, you know, their garage, their driveway. Fiber will help to reduce that. So from durability to just the aesthetics, fibers can add a complete wealth of benefits to your project at a low cost, and we'll talk more about that here shortly. Okay, as far as the types of fiber, like I said, I look back to see what Safety Supply has ordered in the past, and it was mainly microfiber, two different types of microfiber that I'll share with you here shortly. But you know, fiber as a whole, there's basically three different types. There's micro synthetic fiber that you see there on the left. In the middle, you see the macro synthetic fiber. Again, you're getting into what we refer to as a structural fiber, and I'm sure you're all familiar. Everybody seems to be familiar with steel fiber if they're familiar with any macro fiber. Both the macro synthetic fiber and the steel fiber are considered macro fibers. So in terminology speaking, you know, when engineers refer to it, even when I refer to it, when contractors like yourself refer to it, typically we refer to the microsynthetic fiber as microfiber. We refer to the macrosynthetic fiber as macrofiber, and we refer to the steel fiber as just that, steel fiber. But again, the reason I share these with you is because both the macrosynthetic fiber and the steel fiber are macro fibers. Now, beyond this, we get into what I mentioned a little while ago, where we have blended fibers. We might have a macrosynthetic fiber blended with a microsynthetic fiber, or we might have a steel fiber blended with a microfiber. Okay, and we'll talk more about that shortly, but I just wanted to share this terminology because when you see microfiber and macrofiber and steel fiber, these are the products that I am referring to. As far as your micros versus your macros, you know, your micros are very, very fine fibers. They don't tend to be big in diameter at all, actually very, very small in diameter, and not near the length of the macro fibers. So just wanted to share that with you as well. So let's talk about microfiber and microfiber alone right now. So in the short term, you heard me mention a few of these terms, but in the short term, what does microfiber do for you? Well, it handles plastic shrinkage, settlement, reduced bleed water, which you'll see, I believe, on the next slide. It creates a uniform bleed at the surface, which we want. We don't like seeing, puddles of water or wet areas at the surface when we're finishing concrete. But as far as the long term, reduces the permeability of the concrete, provides impact resistance, provides abrasion resistance, shatter resistance, explosive spalling, if you're familiar with that. Applications for microfibers, again, it can range from, as it says, everyday concrete, sidewalks, driveways, tunnels, outdoor placements, shotcrete, even industrial slabs. We just look at every project on a case-by-case basis, and that's something else I'll tell you. You don't have to be the fiber expert. If you don't know what to use, you can certainly reach out to Safety Supply. They can reach out to me, and I can tell you what fiber you need and how much fiber you need to use in a particular, or on a particular project. So you don't have to be the fiber expert. So don't think we're throwing you to the wolves. So we will help you just as much as we possibly can. Here's just a slide that I was talking about as far as the uniform bleeding and what it does. So it does provide for uniform bleeding, because you've got to understand this fiber is in this concrete. It's homogeneous throughout the entire concrete, meaning that you have the same amount in the top of the concrete as you do in the bottom of the concrete, as you have on the left-hand side and the right-hand side, and so on. So just a little something that extra that it does. As far as testing for for the fibers, as far as the microfibers go, the standard test is ASTM C1579. That shows you the picture there on the left, shows you the tray that we load the concrete in, the test specimen in, and then on the right it shows you how it works, just simply blowing air. So what you're doing, you're drying the surface of the concrete faster than the concrete is curing within. So that's where you get your plastic shrinkage cracks, your temperature cracks, and things like that. So that's the test. As with any product out there, there seems to be some sort of ASTM test associated with it. Well, this is the test that we use with our microfiber. Again, ASTM C1579. Nothing that you need to be concerned about, but you could see that spec show up in a specification on a project that you might be working on, where it says, fiber must meet ASTM C1579. Well, our fibers do. All of our microfibers do. So anyway, just wanted to share that with you. Now, as far as the two products that Safety Supply has ordered in the past, and maybe some of you there have used them, are these two products here, the Sika Fibercast 500 and the Sika Fibermesh 300. Okay, the difference between these two, the Fibercast 500 is more of a monofilament, and if that term sounds familiar, a fishing line. Okay, so think of a fishing line when you hear monofilament. Well, the Sika Fibercast 500 is more of a monofilament, whereas the Sika Fibermesh 300 is our fibrillating fiber. And you're going to see a better picture of it in about 2 slides. But, a fibrillating microfiber will do everything that a monofilament microfiber will, but it will it will provide additional security when it comes to drying shrinkage. So you get a little more help on your drying shrinkage cracks or crack prevention with the Fibermesh 300. But these two products are the products that I had found that Safety Supply had been ordering. I did want to share one other product with you. This is our Sika Fibermesh 150. This is a multi-filament product that we sell a lot of in the States. It's just another microfiber that we have, and again, whether it's the 150 or the 500 or the 300, all of these products are great products to use on residential projects. Typically on if you're using a microfiber on a commercial or industrial type project, you would step up to the 300, the Sika Fibermesh 300. That's a great choice for industrial commercial projects because it is a fibrillating fiber. Now, here's what I wanted you to see down here on that bottom picture, the Fibermesh 300. When I talk about fibrillating, well, if you pull those strands apart, you see it looks like a netting. Okay. And that's what we're talking about when we say fibrillating. Okay. Not only does it have the ability to fray along the strand, but it has this netting, and you can tell that those little openings within the net are all about the same. Okay, they all are pretty much the same. And again, it's about surface area. Okay, so the more surface area you have, the more the paste has to bond with and stuff. So it tends to hold things just a little bit tighter. But I just wanted to share these two, especially that photo there on the bottom with you regarding the Fibermesh 300. That's what when you hear fibrillating fiber, that's what they're talking about. Most of your micro fibers that are fibrillating, that's what they look like, when you pull them apart. Now, when you hear of a fibrillating macro fiber, we'll talk more about this shortly, but I'll go ahead and tell you this note. You don't get this same action here with that netting. You get more of a fraying, and the ends start to tear apart and stuff. Again, it's all about surface area that the paste within the concrete has to bond to, but the fibrillating macros don't fibrillate like the fibrillating micros. So, okay, and again, I did mention to you a minute ago that the Sika the 300 helps with the drying shrinkage, whereas your monofilaments or multifilaments micros don't. As far as your microsynthetic fibers, most of your monofilaments or what we refer to as multifilaments, we dose concrete anywhere from 1/2 pound to 1.5 pounds per yard of concrete. And then for the fibrillated products, anywhere from 1 pound to 1.5 pounds. We have done some heavier dosage rates to replace some heavier welded wire fabric, but typically it runs anywhere from 1 pound to 1.5 pounds. Now, this is very important here. No amount of microfiber will provide any structural integrity to the concrete. So you can put as much microfiber in your concrete as you want to, but as far as structural integrity, and when I say structural integrity, I'm talking about, for bending moment, it provides none. Okay, microfiber is not going to help you when you need structural integrity. You need a macro, and we're going to get into that. So I just wanted to throw that note out there to you. Some people think, well, wait, what if I put 5 pounds of, the 300 in there? Well, you're going to have some great crack control and probably overdoing it, but no structural integrity provided to the concrete whatsoever with microfibers. It's for crack control and crack control only, whether it's your plastic shrinkage cracks, your temperature shrinkage cracks, or your drying shrinkage cracks. That's what it's all about, is just crack control. Okay, moving forward, macro fiber. This is something that it doesn't appear that Safety Supply has done much of. Would like to get them going that way, and that's why I want to share this with you, because this is an excellent product to really leave out, to be able to remove, I say leave out, but remove welded wire fabric from slabs, to remove even rebar from slabs. And I'm talking rebar, probably as large as number 5 rebar. When it gets much larger than that, it's hard for me to design a slab with fiber and take the rebar completely out of it. So really up to about a number 5, and and even so with your number 5 rebar, I can't do it in every case. It just depends on where the engineer has designed, the rebar, where it's located. Is it in the top of the slab? Is it in the middle? Is it in the bottom? If it's in the bottom, it's in there for one reason, and that's for structural integrity. It's in there for bending. If it's in there in the top, 1/3 of the slab, then typically it's in there for additional crack control. So again, as I told you in the beginning, we look at every project on a case-by-case basis when we look at removing the steel in the slab and replacing it with fiber. However, if we do that, we are doing it with a macro fiber. And if you remember the type fibers that I told you with your macro fiber, you have steel fiber, you have the synthetics, and then you have what I mentioned. I didn't show you a picture, but mentioned them to you, the blended fiber. So from a technical perspective, in other words, from the engineer's perspective, what does it do? Well, it provides for excellent crack control, like the micros will, especially a fibrillating macro fiber will do everything that a microfiber will do when it comes to crack control. It improves the impact resistance tremendously, no corrosion or spalling. We talked about impact and spalling with the micros, but this goes to a different level here with the macro fibers. Reinforcing in the correct location. So what I'm talking about there is I shouldn't say most, but many slabs that I go out to and watch, being poured that have welded wire fabric on them. Where do you think that welded wire fabric ends up? It ends up in the bottom of the slab, and it's not doing anything, for that concrete in the bottom of the slab. So that's what I mean there when I say reinforcing in the correct location. Now, full depth reinforcing. So this is where, and you'll see something mentioned about this later on in the presentation about 3-dimensional versus 2-dimensional reinforcements. So with welded wire mesh or welded wire fabric, as I call it, and rebar, you are only getting 2-dimensional reinforcement with that. Whereas with fiber, you're getting 3-dimensional reinforcement. Understand, like I said before, that fiber is sitting in that slab. It's homogeneous throughout the slab, same amount in the top as the bottom, as there is in the left part of the slab, on the right part of the slab, and it's in there at all different angles. So, that's what I mean when I refer to full depth reinforcing. It's 3-dimensional reinforcement that you're getting in your slab. So what does that mean from your perspective as whether you're the GC or the finisher or what? You don't have to place welded wire fabric. You don't have to mess with that anymore because it's coming in the truck. Typically it gets put in the truck at the concrete plant. With your case, it might be a little bit different in Barbados. You guys might do it yourself and probably would do more of that than over here in the States. We typically have the ready mix producers put it in, but either way, it eliminates the handling and even chairing or standing on the welded wire fabric and pulling it up during the concrete placement. It eliminates that. It eliminates pumping. Okay, so what that means is maybe you had a number 3 rebar on 12-inch centers chaired 2 inches from the bottom of the slab. Well, you can't drive on that. So you'd have to pump it. Well, in this case, like I said, the strength is in the truck. So in the concrete truck. So it eliminates pumping. Less labor, much less labor. When you talk about, replacing welded wire fabric, especially rebar, you don't have to handle the rebar. You don't have to tie the rebar. You don't have to chair the rebar, much less labor involved. Fewer accidents. I didn't realize that fewer accidents was as big a deal until I started talking to more and more contractors, and it's a really big deal as far as tripping hazards. So, fewer accidents with much fewer accidents with fiber versus traditional welded wire fabric or rebar. It's simple, it's quick. Like I said, the integrity, whether it's for just crack control being a microfiber, or structural integrity and crack control being a macrofiber. Again, it's coming in the truck. So when the concrete goes down, so does the reinforcement. So anyway, those are the things that you'd be looking at from your perspective. So, okay, going back to talking about the macro synthetic, the steel, the blended. If you notice there, the fiber, like the picture on the left and the picture on the right, you see what we refer to as a puck. I sent a sample of a puck. I don't know if they got there in time. They should have, but I sent 2 glass jars. I sent a puck that was intact, and I sent loose fiber from a puck. So we puck our fiber, okay, meaning that our macro fiber, not our microfiber. We puck our macro synthetic fiber, and it's wrapped, and you have thousands of fibers in there, and they those pucks are in a bag when you receive it. So it's a water soluble bag. We throw the whole bag into the truck. You don't dump them in or anything like that. But it's all in the design of the fiber as to why the fiber is pucked, because we use the bags to get the fiber into the truck. As the truck starts mixing it, the bags move through the concrete, the bags disintegrate, the pucks are then exposed to the concrete. They move through the concrete, and then the wrap on the puck, which I'll talk to you more about in a few minutes, dissolves, and the fiber explodes and goes everywhere in the concrete. Now, if you remember what we talked about, again, that's not microfiber, that's macrofiber, steel fiber, and then blended fiber. Okay, our blended fiber could be either steel with micro, or a macro synthetic with a microfiber in it, which I'll show you the names of those products here shortly. But which they use we sell a lot of. We've got 2 products. One is a steel, like you see there in the middle with a synthetic micro, and one is a macro synthetic with a micro synthetic. So still see a lot of that being used, but it's really not needed when you're using a macro fiber, a macro synthetic fiber that is a fibrillating fiber. Because remember, I told you it does everything that a microfiber does and more. Now, as far as the macro fiber, is there a difference in macro fiber? Are they all the same? There is absolutely a difference, and they are not all the same. Even our fibers are not the same, but they vary tremendously from supplier to supplier. And I'm going to show you some names of some of our competitors and stuff. I'm not afraid of my competitor. I know what my fiber does, and I know how their fiber performs, so I'm not afraid of my competitor. But no, they're not all the same. So that's something to keep in mind. As you'll see here shortly, one of our particular fibers, our new fiber, which is extremely strong. I can do a project with much less fiber per cubic yard of concrete than most of the fibers on the market from my competitors. So we'll talk about that more here in just a minute. So when it comes to macro fiber, we basically look at 3 things. We're looking at the anchor strength that they have, meaning, how they anchor in the concrete, the tensile strength that they have, meaning, how much strength does it take to pull one apart, the aspect ratio, which I'm going to share with you here in just a minute. Common term in the fiber market, aspect ratio, meaning the length over diameter. Fibers with high aspect ratios are high performing fibers. So just keep that in mind. If you've got an aspect ratio of like a 1.06, that is a high performing fiber versus a 0.52 or something. So anyway, we'll talk about all of these things. As far as the tensile strength goes, what you see here is a lady in a lab this is actually at our lab in our plant. We do internal testing and stuff for quality control, but as far as the actual testing, we do all third-party testing. We do not do any test reports or anything based on internal testing. We send our fiber out to a third-party lab and have them test it. It just makes more sense. It's more credible at the end. So anyway, what you see her here is testing the tensile strength. All she's doing is pulling fiber apart to test the tensile strength of the fiber. So let me tell you something. When it comes to synthetic fiber and steel fiber, in most cases, you can use a macro synthetic fiber anywhere you could use a steel fiber. Now I like to ask this question when I'm doing in-person presentations. I always ask, well, what do you think stronger, steel fiber or a macro synthetic fiber? And I'm talking about one fiber, just a single fiber. And everybody, all the attendees think I'm setting them up, and they say, oh, the macro synthetic fiber, and that's not the case. A steel fiber is stronger than one single, steel fiber is much stronger than a single synthetic fiber. But where the difference is made is in the number of fibers that you get in a pound of macro synthetic versus a pound of steel fiber. Okay, much more fiber in a pound of a macro synthetic fiber than in a pound of steel fiber. So just a neat little note I like to toss out there. As far as anchoring types, the most common, one of the most common fibers on the market right now is that single hooked in steel fiber that you see there at the top. There's all different types. It can be crimped, embossed. As I told you, it can be fibrillating, meaning, with the macro fibers that it's fraying along the strand of the fiber, or it's splitting at the ends of the fiber. And again, it's just providing more surface area for that fiber to embed in the concrete. Then we talk about, controlled pullout, controlled crack, ductility, and things. There's all different types of fiber designs on the market. For instance, the one you see there at the bottom, that's actually a macro synthetic fiber, but it's crimped. Okay, and the crimp is what helps it with the pullout. So just think it's much easier to pull something that is flat and straight out of a material than it would be to pull something that has a texture, a crimp to it. So there's all different. You'll see designs of steel fiber with the single hooked in, like you see up there. You'll see a double hooked in, and then you'll see sometimes a triple hooked in. Okay, so again, all different types. As far as the aspect ratio, here's what I was talking about. I mentioned it earlier, and I mentioned it again just a few minutes ago. It's the length to diameter. The higher the aspect ratio, the better performing the fiber is. You get a better embedment. As it says, you get more fibers per pound, and that is nothing but the length over the diameter. So it's a term that's used all the time. There's another term that you may or may not be familiar with. It's called denier, D-E-N-I-E-R. And that's a very, very common term in the fiber industry. And what that means is if someone says, well, that particular fiber has a 150 denier. What that means is that 9,000 meters of that particular fiber only weighs 150 grams. 9,000 meters. That's a lot of fiber. Only weighs 150 grams. We have fiber that have very, very, deniers that are under 20. So, just think about that. 9,000 meters of a fiber that weighs 20 grams or less. That's a very, very fine fiber. So the lower the denier, the finer the fiber. So not sure if you've ever heard that term before. A lot of people, have not, but I like to introduce that to you anyway. I think it's really neat, to say that 9,000 meters of a fiber only weighs, I don't care if it's 150 grams. That's just not a lot of weight for 9,000 meter length. This is just a neat little slide that talks about some terms here that, as far as the anchoring, the tensile strength, of course, the tensile strength is the fiber itself, pulling apart. The anchorage is the fiber pulling out of the material that it's embedded in, which what we're talking about is concrete. So just a neat little slide here, just showing you, things as far as the anchorage, the tensile strength, and so on. Okay, so I've mentioned quite a bit of these, but why should you consider macro fiber? It's simple, it's quick. We mentioned that one. We mentioned that that it can eliminate the welded wire fabric. I mentioned that that we can eliminate in many cases, not all, but in many cases we can take the rebar out of the slab and replace it with fiber. It decreases the labor, as we talked about. It's extremely cost effective with the cost of steel right now. And listen, over here in the States, contractors are having a hard time finding welded wire fabric, and when they do, it's extremely expensive. So right now we are extremely cost effective. I mentioned earlier it decreases accidents. Excellent crack control. We've talked about that. We've talked about how it improves impact resistance, no corrosion or spalling, especially when you're talking about a macro synthetic fiber, because it's made out of, in our case, and in most cases for most manufacturers, it's made out of polypropylene. It's typically a polypropylene polyethylene blend, but those two materials are inert materials that they don't absorb water. They're plastics. They're made from hydrocarbons, so they don't corrode. Now, steel fiber, it can corrode, and there are occasions where we don't use steel fiber because of that in wet areas and things like that, especially in the food industry. If we're doing a big warehouse slab or something with the food industry and stuff, or coolers or freezers and things like that, typically they like to stay away from the steel fiber. Reinforcing in the correct location, we talked about that, and full depth 3-dimensional reinforcing. Again, remember, it's homogeneous throughout the mix. It's 3-dimensional reinforcing versus the 2-dimensional reinforcing that standard welded wire fabric and rebar provide. Now, this is a really neat diagram here that I just want to share with you. And this is the way we test our beams. We basically, or test our fiber, I should say. They are beams, but the way we test our fiber. You've got a 6-inch by 6-inch concrete beam that's 20 inches long that's embedded with fiber. Well, if there was nothing in the beam and we load it, as you see in the upper right hand, I don't know if you guys can see my mouse, but if you see this up here where I'm circling, it's simply supported on the ends, it's loaded in the middle, and it's deflected to 3 millimeters as seen over here. Okay, we'll test it until it deflects 3 millimeters, but before it gets there, it cracks. Okay, so we're loading it, and then right up here at this F sub R is where the concrete cracks. Well, at that point, if there's nothing in it, this is what happens. Okay, it would come straight back down because concrete, is strong in compression but weak in tension. Okay, so if there's nothing in there, no steel, no fiber, no nothing, then it goes up, it cracks, and then that curve comes straight back down. Well, what you see, and I'm going to do away with that. What you see here is when it realizes that, hey, I've got some help in here, there's fiber in here. So it starts to come down, then it realizes that there's some tensile strength in there. So this is what the fiber allows it to do. Now, RE3, I don't know how familiar any of you are with this. If you've ever seen it in any specs, especially, big warehouse slabs or big box slabs or anything like that, a lot of times they'll have an RE3 value. And basically, it's the FE3 value, where the concrete ends after 3 millimeters of deflection versus where it cracked. Okay, it's just a fraction. I mean, you'll see an RE3 of 23% or an RE3 of 50%. So anyway, that's what that RE3 value is. Again, I'm not sure if any of you are familiar with that, but that's what it's referring to. It's referring to, you know, where does it, what's the load on it at 3 millimeters, and then what was the load on it when it cracked. It's just simply a, you know, a fraction of those two values. So talked about that. Okay, when it comes to this thing up here, let me get rid of this if I can. And bear with me. Well, I can't get rid of it. Anyway, when it comes to macro fiber, there are two ASTM tests, just like the 1379 test that our 1579 test that I shared with you regarding the microfiber. Well, there's two tests when it comes to macro fiber. It's ASTM C1609 is one test, and this is the test that is more real world. This is more what's actually happening in the field with the concrete when it's placed. Again, simply supported. It's loaded, as you see there in that picture on the right, and tested to 3 millimeters of deflection, just like what we talked about. With ASTM C1609, it deals with what I was just talking to you about, the RE3 value. Okay, it deals with the residual strength value. Now, oops, hang on. Here we go. Okay, so it deals with this guy right here with RE3. Okay, again, this is what the industry, this is the spec. It's been recognized for many years now. This is the spec that the industry tends to use versus the other one that I'm getting ready to tell you about. So, you know, the equivalent flexural residual strength ratio, all it is again is you know, what's the load on the concrete when it reaches 3 millimeters of deflection versus where it cracked. Now, the other test that is out there is the ASTM C1399 test. I want you to look at this photo on the right. Okay, look at this photo good, and then I'm going to go back to that photo of the C1609. What do you see in there? Same loading cell, might look a little different, but it's the same loading cell, loaded the same way, simply supported on the ends, loaded in the middle, you know, with the 2 points. What do you see different in that? Look at the bottom of that. Look at the bottom of that beam. And look at the bottom of that beam. You see that steel plate in there? Okay, that's the difference between 1609 and 1399. This is not really what's occurring in the field, what the concrete, the way the concrete, you know, feels the load in the field. So basically, this test, the way this test is run is the concrete is loaded until it cracks, and once it cracks, they unload it. And at that point, they take the steel plate out, and then they start loading the beam again. So that's why it starts back at 0 again and then finishes out over here. It's very similar, but not, you know, it's not nearly accepted as 1609 is, and actually 1399 is going to it's going away. So you know, we don't, I would anticipate in the next 2 years that 1399 becomes obsolete. But you could see specs with either, you know, calling out C 1609 or ASTM C 1399. Now, the difference with this is that I told you ASTM C 1609 was based on the RE3, which if you've heard, if you've seen anything in specifications or anything, it would have been the RE3 versus this guy, the ARS value, which is the average residual strength. So it's got a different name. Typically, these values are higher than the RE3. But again, it's tested completely different, and C1399, you know, like I said, I would think maybe in the next 2 years that specification will be obsolete, no longer accepted by the industry. But I did want to share it with you because you very well could run into a project where, you know, the engineer has specified an ARS value versus an RE3 value. So ARS and RE3 are not equivalent. So You know, if you have any questions regarding that, or if you run into that in the future, by all means, feel free to reach out to me directly, or reach out to Safety Supply, and we will help you, you know, determine what you need to use. As I said, our macro synthetic fiber comes in pucks and water soluble bags. Okay, the only fiber, the only macro fiber that we don't puck is steel fiber. You know, we don't puck our steel fiber. We don't manufacture our steel fiber. We do manufacture all of our fiber except for our steel fiber. So our microfiber, our macro fiber, or macro synthetic fiber, we manufacture that. We don't buy that fiber. Okay, there's only just very, very few companies in the United States. I'm going to speak for the states. In the states that actually manufacture their fiber, we are one. So we control our own destiny when it comes to that. The fiber market has gone crazy right now because of the price of steel, because of the availability of welded wire fabric, and luckily, since we do produce our own fiber, we're in much better shape than a lot of our competitors. So. Anyhow, these are pucks, and what I wanted to tell you was that wrap on there we refer to as PVA or PVOH, and what that is this same material here. I'm sure you're probably familiar with the Tide pods, the laundry detergent pods. It's the same material. It just, you know, it dissolves when water gets on it. So just wanted to share that with you. But our fiber does come in, you know, comes pucked. And it's designed that way. You know, it's designed to be pucked. And in many cases, in most cases, we don't want loose fiber in our bags. We want pucked fiber in our bags. So it does distribute throughout the concrete the way it needs to. Okay. I don't know if they had an opportunity to provide you some sheets I sent you, but I did want to talk to you about two different macro fibers. That, you know, chances are if you called me up, it would be one of these that we would be using in Barbados. It would be our Fibermesh 650. Again, there's the Fibermesh name. That was a Fibermesh product, the 650. And the one below it is our new fiber, the 800 Stealth. If you've noticed up here in the upper right-hand part of the slides, you've seen this little, looks like a stealth fighter, and the term stealth. Well, that's our new fiber that we have out. It is very strong. It finishes beautifully, and we're going to talk more. I'm going to talk more about the stealth here in just a minute. You know, with the Fibermesh 650, it's a great product. Finishes, you know, fairly well. We would use anywhere from 3 to 7.5 pounds per cubic yard of concrete. With the 650, as far as the stealth goes, we do anywhere from 3 to 9 pounds right now. We're actually looking to get that up to about 11 pounds. But really, you know, those type dosage rates are few and far between. Very, very seldom do I see a 10-pound dosage rate. I have done them in the past, but they're few and far between. You know, your typical dosage rates are your 3s, 4s, and 5s, and 7.5 is actually a very common one. I've done projects recently with the 800 Stealth at 7.5 pounds of fiber per yard of concrete, and I did a project with 8 pounds of fiber per yard of concrete. Again, it's an extremely strong fiber, high aspect ratio, performs beautifully, finishes beautifully, and that was the key. You know, that was our goal with that particular fiber, was to have a fiber that was strong but would finish beautifully. And that fiber, what we like to say is that fiber has no memory, meaning that when it bends and you lay it down, it stays down. So when you hit it with your, you know, hard steel trowel, it stays down. I've done a couple of jobs where it was a broom finish, and it brooms beautifully. Speaking of broom finishes, what I will tell you, the key to doing fiber reinforced concrete, to brooming it, is you broom it one way. Do not push and pull the broom over the same area of concrete with fiber in it. I don't care if you've got microfiber in it or macro fiber in it. I don't care how much fiber you have in it. Don't push and pull your broom over the same area. If you push it one way, then move over and pull it back, move over, push it, move over, pull it. You know, you could do that, but don't push and pull over the same area of concrete because it tends to stand the fiber up, and nobody wants to see a hairy slab with fiber sticking up. Of course, if you have it, you can burn them off. You know, what I will say is take caution to burning off anytime you would burn off fiber. And typically that's going to be macro fiber that you're doing, because you don't want to shock the concrete with extreme heat. So you don't want to hold your torch on the concrete any longer than you absolutely need to. So anyway, just a neat little note. Okay, as far as our macro fibers go, these are some more that we have. I talked to you about the 650 and the Stealth. We've got a product we call Prime. We've got a product we call Mirage, and so on. And then the steel fiber, again, we do not manufacture any steel fiber. But if you need steel fiber, we can get you steel fiber. So, just you can keep that in mind. So we sell steel fiber, but, I'm not a big steel fiber engineer. I love macro synthetics, and I try to flip every steel fiber job that I come across to a macro synthetic. And then we have the two blended products. The 850 is the steel with steel fiber with the micro synthetic, and the 950 is the macro synthetic with the micro synthetic. So certain areas of the United States use these products quite a bit. Not a big user here in my territory in the Southeast, but I do use a lot of Stealth, quite a bit of the 650. So anyway, just wanted to share those with you. When it comes to macro synthetic fibers, anywhere from 3 to 20 pounds per cubic yard. We do not promote 20 pounds per cubic yard. For fiber, we don't do it. There are companies out there that do it. One I used to work for, they promote that, but never known them to do a job that high. But anyway, you could see anything up to 20 pounds. Again, that's not typical, but like I said, your typical applications are your 3s, 4s, 5s, 7.5s. As far as steel fibers, they could range anywhere from 15 to I've seen 110 pounds per cubic yard of steel fiber. Just think about that, 110 pounds of steel fiber per yard of concrete. I mean, a 10-yard truck, you'd have 1,100 pounds of steel fiber on that 10-yard truck. Sounds like a lot, but I've seen it. Typical dosage rate for a steel fiber is going to run anywhere from 25, 26 pounds to 55, 60 pounds. Those are what we see the most of. So again, I have seen 110 pounds per cubic yard, but those are few and far between. So neat note here. No manufacturer out there will allow you to use anything less than 3 pounds per cubic yard of a macro synthetic fiber. It's just the industry standard. We don't look at anything less than 3 pounds. It's just, like I say, it's just the standard that we use. So, if the specification calls for 3 pounds of a particular fiber, well, that's going to be 3 pounds of a Sika fiber versus 3 pounds of a Euclid versus 3 pounds of a Forta or a Grace. It's 3 pounds. But where we can become competitive is when you run across a spec that calls out maybe 5 pounds of our competitor's fiber. That might only take me 3 pounds of mine. And we're going to talk more about that here in just a minute with the Stealth fiber. Okay. Something I wanted to tell you about is when it comes to, to decks, steel decks, they do allow the use of fiber in steel decks. Minimum dosage, minimum dosage for steel fiber is 25 pounds per cubic yard. Minimum dosage for macro synthetic fibers is 4 pounds per cubic yard. So this is big business for the fiber industry. We replace a lot of welded wire fabric and rebar too in composite metal decks. So something to keep in mind. This is what SDI allows for. Again, these are minimums. It takes a minimum 25 pounds of steel, and the reason it's all about the the burning aspect for the D700, D800, D900 floor ceiling design, and that's where UL comes into play. So every fiber on the market will not have a UL certification. My 650 product has a UL certification. My Stealth product, we have a certification, UL certification on. So if you are required to meet, the UL certification on an elevated deck, make sure that any fiber that you're using meets that. And not only will it have to meet, the UL, it has to meet those minimums right there as well. So again, fibers aren't just used for slab on grade. They're used for elevated slabs as well. What I will tell you is we don't do what I refer to as a true supported slab. We will not replace the steel in a self-supported slab, meaning that they've got rebar in the concrete. There's no decking or anything like that, and we don't pull that out and replace that. So we don't that's a no-no for the fiber industry. But again, the decks, the metal deck applications, absolutely, that's big business for us. So I want to talk to you about this guy, because if I send you any macro fiber, this is most likely what you're going to be getting, and I want you to remember this product, because it is an excellent macro fiber. It's one of, if not the strongest on the market right now. It doesn't cost any more than any of my other fiber or any of my competitors' fibers, and that's a really cool thing. You get a premium product for the same price as everything else on the market. Again, the reason we call it stealth is because of that note right there. The best fiber is the fiber you don't see. Nobody wants to see fiber in their slab and stuff. Now, can I tell you that if you use the stealth product, you're not going to see a fiber or some fiber? I'm not going to tell you that, but you shouldn't. If it's finished correctly and stuff, especially hard trowel steel finish or hard steel trowel finish, you should not see any fiber. So when it comes to this fiber, as you can see in the little picture there, going opening up, it's basically a quad lobal fiber, meaning there's 4 fibers together that you have a hard time seeing that. And what they do is, we talked about aspect ratio. Well, when they're together, when all 4 of them together, they're not such a high aspect ratio, but as they start to separate and to fibrillate, that's where those single fibers become or have that high aspect ratio. And remember what I told you about, high aspect ratios. A high aspect ratio is a high performing fiber. As it says in that bottom right hand note, you have approximately 38,000 pounds of this fiber. 38,000 fibers in a pound of this particular fiber. And then when it's mixed up, you could have 150,000 or more because of the way it breaks up. Okay. And when it breaks up is when it's actually stronger and higher performing than when it's together. I know that sounds like it doesn't make sense, but it is. So it's 1.5 inches long, as it shows there. It is very, very strong. So, just keep this in mind. It is a crimped fiber. It's self-fibrillating. You can see the very first note there. It talks about the low memory. Remember what I told you? I said it has really no memory, meaning that when you push it down, it doesn't remember that it was straight. Now it thinks it's bent, so it stays bent. High fiber count. So anyway, this will be most likely, unless you call up or Safety Supply calls up looking for a different macro fiber in particular, this will be the fiber that we go with because of how well it performs. It's strong, as I told you. It finishes beautifully. And again, it doesn't cost any more than any other macro synthetic fiber that we manufacture or our competition manufacturers. I mean, in many cases, you know, I'm lower than my competition is right now. But again, keep in mind what I told you. We manufacture our fiber, whereas, you know, a lot of these manufacturers are not manufacturers. They're fiber companies, but they don't manufacture it. They resell. So anyway, again, extremely strong, finishes beautifully, and doesn't cost any more than anything else. As far as the competition, you know, I mentioned some names to you. You're going to see a few of those names pull up here. I think this is a neat little slide. I just put it together just for your viewing pleasure. These are my two big competitors. Not sure if you've ever heard of these two companies over in Barbados, but Forta Fiber, great product, nothing wrong with it. Euclid, their tough strand fiber, not a bad product whatsoever. You know, again, I'm not afraid of my competition because I know what my product can do, and I know the limits of their product as well. So, you know, as I just said, I'm not afraid of my competition. Why? Because I know what my products can do. I'm not going to badmouth somebody else's products. I'm going to tell you, you know, what I can do. I'll tell you what they can't do, but that's just being honest. But I'm not going to I'm just going to give you the facts. But as I say here, they better be afraid of the Sika 800 Stealth. You can see a few more names down there at the bottom, and then here's what I did for your viewing pleasure. The little stealth fighter coming through, destroying my competition, and it will, as I'm getting ready to show you. So. All fibers are not created equally. Remember the two cars? I showed you the little gremlin, and then I don't know what the other one was, some little high-tech hot rod. You know, 3 pounds, as I stated before, is the minimum dosage rate. But Sika, the 800 Stealth, absolutely sets itself apart from the competition as the dosage rates increase. Remember, I told you if it's calling for 3 pounds of fiber, then it's going to be 3 pounds of fiber. We're not going to say, oh, well, you can use a pound of Stealth. It'll be 3 pounds of Stealth. So, but where we do differentiate ourselves are things like this: 5 pounds of tough strand, we can use 3 pounds of Stealth. 5 pounds of Forta, I can use 3 pounds of Stealth. 7.5 pounds of tough strand, I can use 5 pounds of Stealth. 7.5 pounds of Forta, I can use 4 pounds of the Stealth. So look at those numbers versus these numbers, okay? You know, and I mean, it's significant. I mean, when you figure, I don't know what the fiber sells for over there, you know, but you know, that can be some significant money, especially on larger pours. So anyway, just a neat little note to keep in mind. You know, we talked about the RE3 value. If you see that, that's what this chart is showing as far as the dosage rate. And the RE3 value that you achieve. Of course, the higher the RE3, the better, or the stronger the slab. So if you look at the yellow line, that's where the Stealth performs, whereas my competitor, one of my competitors that is probably my biggest competitor of the ones I just showed you, the gray line shows, you know, their performance as far as their dosage rates and the RE3 values. So the SikaFiber 800 Stealth is an awesome product, and if you guys, you know, are looking to use the macro fiber, that's the product we want to provide you, because it will, you know, stand out above the rest. Okay, that's all I have for you. And now we'll take, if you have any questions or comments or anything like that you'd like to ask or to say, we've got some time to do that. So I will send it back to Safety Supply and see what you guys, if you have any questions.